Have you ever wondered if we're alone in the universe? For centuries, this question has fueled our imagination, leading to countless stories of alien visitors and interstellar voyages. And sometimes reality is even stranger than fiction. Remember Oumuamua? That bizarre, cigar-shaped object that zipped through our solar system back in 2017? It was our first confirmed interstellar visitor, and it left scientists scratching their heads. Was it a comet? An asteroid? Or something else entirely? One of the most puzzling things about Oumuamua was its speed. It accelerated away from the sun faster than gravity alone could explain, almost like it had its own engine. This led to some wild theories, including the famous and controversial idea from Harvard astronomer Avi Loeb that it could have been an alien artifact, a light sail, perhaps. But Oumuamua never slowed down. It just kept going, eventually disappearing back into the vast emptiness of interstellar space, leaving us with more questions than answers. It was a cosmic hit-and run. Now, fast forward to today. A new interstellar visitor has entered the scene, and it's doing something completely different. Its name is Comet 3I, ATLAS, and unlike Oumuamua, it has decided to stick around. This comet just did what Oumuamua couldn't. It hit the brakes. And the story of how it did that is just as fascinating as the mystery of Oumuamua itself. It's a tale of a cosmic dance between the giants, a gravitational slingshot, and a discovery that's changing our understanding of how our solar system welcomes newcomers. So, how did Comet 3I, ATLAS, manage to become a permanent resident of our solar system? The answer lies in a perfectly timed cosmic billiard shot. When it was first discovered in early 2023 by the Atlas Survey in South Africa, astronomers quickly realized it was on a hyperbolic trajectory. In plain terms, that means it was moving fast to be captured by the sun's gravity. It was destined to be another Oumuamua, a one-time guest, just passing through. Its path was predicted to take it swinging around the sun, and then right back out into interstellar space. But the universe had other plans. Researchers Chi-Cheng Zhang and T. Coretta decided to rewind the clock, tracing the comet's path backward in time. What they found was astonishing. In the distant past, long before it reached the inner solar system, Comet 3I, Atlas had a very close encounter. It wasn't with a small planet or an asteroid. It was a close pass with not one, but two of the biggest players in our solar system, Jupiter and Saturn. This wasn't just a casual flyby, it was a gravitational masterclass. As the comet approached these gas giants, their immense gravity grabbed hold of it, acting like a giant cosmic brake. Imagine you're on a skateboard rolling down a huge ramp. You're going fast, way too fast to stop. But then your friend, who's much bigger, grabs you as you fly by and slows you down just enough for you to turn and enter a different path. That's essentially what Jupiter and Saturn did to Comet ATLAS. This gravitational assist, or in this case, a gravitational de-assist, was so powerful that it dramatically altered the comet's trajectory. It bent its path, changing it from a one-way ticket out of the solar system into a long, elliptical orbit around our sun. The comet that came from another star is now one of our own. This is a huge deal for astronomers. Oumuamua and the second interstellar visitor, Tuai Borisov, were fleeting moments. We had very little time to study them before they were gone forever. Think of them as tourists snapping a quick photo before hopping back on their bus. But Comet 3I, ATLAS, is different. It's an immigrant. It's unpacked its bags and decided to stay. This gives us an unprecedented opportunity. We now have a piece of another solar system right here in our cosmic backyard, and we can study it for years, even decades to come. Its new orbit is a long one, taking it far out into the Oort cloud. the most distant region of our solar system. It will be a very, very long time before it swings back in close to the sun. But the fact that it's gravitationally bound to our sun at all is the key. We can track it, observe it with our most powerful telescopes, and learn its secrets. What is it made of? What are the chemical signatures of the star system it came from? Does it look and behave like the comets that were born in our own solar system? Or does it have unique properties that tell a story of its alien origins? The capture of Comet 3I ATLAS also helps solve another puzzle. For years, scientists have wondered if some of the comets we see in the distant Oort cloud might actually be interstellar visitors that were captured long ago. Models suggested it was possible, but we'd never actually seen it happen until now. Comet Atlas is the first direct, observable proof that our solar system can and does capture objects from other stars. It's a live demonstration of a process we've only ever theorized about. This makes us look at the Oort cloud in a new light. It's not just a repository of our solar system's primordial leftovers. It could be a diverse collection, a sort of cosmic museum containing artifacts from countless other star systems across the galaxy. So, what about that Oumuamua mystery? Does the story of Comet Atlas shed any light on it? Well, in a way, it makes Oumuamua even more strange. We now have a clear example of an interstellar comet behaving, well, like a comet. It interacts with planets, its orbit changes, and it's made of the ice and rock we expect. Oumuamua, on the other hand, did none of that. It didn't outgaze like a typical comet, which is the leading theory for its strange acceleration, the so-called rocket effect from sublimating ice. And its shape was just plain weird. The capture of 3I ATLAS strengthens the case that Oumuamua was something truly unusual. It highlights just how different it was from a normal interstellar comet like a TLAS or Borisov. Does this mean it was an alien probe? Not necessarily. There are other natural explanations, like the idea that it could have been a nitrogen iceberg shipped off a Pluto-like planet in another system. But what the story of Atlas does is it refines the question. It gives us a baseline for what a typical interstellar traveler looks like. And by that standard, Oumuamua remains an outlier, an enigma that continues to challenge our assumptions. The universe is constantly throwing us curveballs, and each new discovery, like the incredible journey of Comet 3I Atlas, adds another piece to the grand puzzle. From a fleeting visitor that sparked debates about alien technology to a captured wanderer that has become a permanent part of our solar family, the study of interstellar objects is just getting started. It's a reminder that our solar system isn't an isolated island. It's part of a vast, interconnected galactic neighborhood with visitors dropping in all the time. And thanks to Comet Atlas, we now have one that's staying for a very long visit, giving us a front row seat to study a messenger from a distant star. Who knows what secrets it will reveal? Thank you so much for joining me on this cosmic journey today. The universe is full of wonders, and it's a privilege to explore them together. If you enjoyed this and want to stay updated on the latest discoveries from the final frontier, make sure to hit that subscribe button and ring the notification bell. It really helps the channel out. Until next time, keep looking up.